Hello and welcome. In this video, we are going to take another look at for loops, and specifically, we are going to look at for loops that are being driven by Matlab numeric vectors or 1D arrays. And the purpose behind this video, or the purpose behind this script, is then to take the results of some sort of calculation that is done inside of the for loop and then store those values in another vector or 1D array. Now, I've covered this topic in a couple of earlier videos. As a matter of fact, what we're going to do is we're going to revisit two of our earlier scripts and sort of combine them and look at alternate ways to solve the exact same problem. Now, a quick reminder of what we're trying to do here is basically we have a for loop that is driven by this 1×10 vector. In this case, we're calculating the area of a circle using a sequence of radii, basically just doing it one at a time. Now, in the earlier video, we were trying to then store those individual areas into a new variable so that we could perhaps use it then later on elsewhere in some code. But let's go back to start with this to understand exactly what the problem is here. And so to begin with, I'm going to go ahead and create a new variable. I'm going to call it areas. Notice the S here. And I'm going to go ahead and set it equal to a set of empty square brackets, which if you go ahead and run this, if you're not yet familiar with this, this will create a 0×0 array or vector of double. In other words, basically the idea is that I want to iterate through this for loop and simply store the individual area that I'm calculating into this vector based on how many times this for loop runs. Now, the problem with it is I have to be able to leverage an index value to be able to store the individual area into this areas vector. And as we saw in the earlier video, what we did is we created another variable that was just simply a counter that kept track of how many times the for loop had run. And we'll use this approach again when we start working with while loops. But I want to show you another way to go about doing it. And that is going to be to leverage our length function. Now, it turns out we can do the same thing with size as well, but I'm going to do just one example in this video. And that is what we're going to do is we're going to take the areas vector itself. We're going to get the length of the areas vector, and we're simply going to add one more to it. And so what that does is it takes the current length of the areas vector, and it simply says, I want to put the next value in the next location. So in other words, if the initial value, or rather the initial length of the areas vector is 0 for the first loop, well, 0 + 1 is 1, and therefore it says that I want to put the newly calculated area in the index equals to 1 location of my areas vector. And to do that, we simply assign then the value, that singular value of the area, to that location in the areas vector. Now, to appreciate what's actually going on, we'll go ahead and leave the semicolon on here. But what we'll do now is we'll go ahead and highlight, and we will simply evaluate this block of code. And you'll see that in addition to what we did in the earlier example, in other words, where we have the radius, individual radius, and the areas printed in the console, and we also have this temporary or local or disposable variable, however you want to think of it, of the singular area, which only captures then the last value of that loop. But now we also have this areas vector where it has all of the values stored in one variable. And to sort of appreciate again what's going on here, I'm going to add one more line in my script. I'm going to simply keep track of how big the areas are, or that areas vector is, if you want to word it that way. And to do that, I'm just simply going to go ahead and throw in one more display here prior to adding the new area, and we're going to call this, or we're going to just specify here, this is going to be the length. And again, we're going to do a %d because we know that it's going to be an integer. And I will simply specify whatever the length of the areas is. And again, we're getting a number of warnings here. Don't worry about this. This is just because we're using display with our sprintf. And then what I'll do is I'll simply highlight all of my code. Remember that this will essentially overwrite or erase the values of the areas vector. Alternatively, what we could do is we could also put in a clear areas here, but I try to stay away from using the clear function too much. In this case, then let's go ahead and reevaluate it. And you'll see that prior to each of the iterations, basically right after we print the radius in the area, the length of the areas array starts off as 0. And so we simply add 1 to it to establish a location in the areas vector to be able to store that newly calculated area. And again, we could, if you wanted to, you could improve this just a little bit by simply copying and pasting this code down below. And what we'll do here is we'll put a little hint here. This is before, and then this is after. Again, we'll rerun this one more time, and hopefully you'll see what's going on by this point. And you can see that what I'm doing here is as I am adding new values to my areas vector, it just simply grows. Now, I'd like to show you one more way to go about doing this. Now, again, this is going to be sort of combining some previous techniques, but it is going to allow us to get away from one of the warnings that Matlab has. And let's go ahead and take a look at that warning. If you hover over the areas vector, it is complaining. It says that the variable appears to change in size on every loop iteration, which is technically true. And you may get some sort of performance degradation as a result of that, particularly if you have a loop that runs thousands or even millions of times. Now, what we can do is we can break the initial for loop up into its parts, much like we did in the second video where we talked about this topic. And to do that, what we'll do is we'll create another variable called radii. And again, we're going to keep the exact same example here. We're just going to start off with 1. We're going to increment by 1, and we're going to go to 10. However, though, I'm going to write this in such a way that I do not have to worry too much about that. In other words, I can adjust this pretty much on the fly. But what we're going to do that's going to be different is I'm going to come along and I'm going to go ahead and create my areas vector. But unlike before, where I set it equal to an empty set of square brackets, I'm going to go ahead and make it the same length as the radii. And so there's a couple of ways to go about doing this. But again, we're going to keep this one pretty simple. And again, what we want to do is we want to actually have this be the same size as the radii vector. And again, you notice how I'm continuing to say size. That should hopefully provide some sort of hint to you. And what we're going to do is we're going to combine that zeros function that we saw in an earlier vector video, and we're going to combine it with the size function, and we're simply going to specify the radii vector. Now, what does that get us? Well, first thing, let's go ahead and clear the workspace so I can show you that there's no tricks going on. And I'm going to clear the console. And we're simply going to go ahead and run these 2 lines of code, starting with creating the radii. And again, this is going to be pretty simple. This is just a 1x10, keeping it short so it stays on the screen for this earlier example. And then what we're going to do is we're going to leverage then the size of the radii, which we talked about earlier. In this case, it's going to be a 1x10. And well, what happens when we pass that to the zeros function? Well, that constructor simply creates a 1x10 vector of zeros, and then we can simply assign that to the areas vector. Now, what we need to make this work is, once again, we're going to have some sort of index variable. In this case, I'm just going to use the variable index. There's nothing magic about this particular variable name. And I'm going to go ahead and initialize it to 0. And then we're going to write our for loop, much like we did again in that second example that we did in the for loop video. In this case, we're just going to use, again, the radius, and we're going to say for radius equal to radii. Make sure to have your end. Remember, the for has to have a matching end. And then what we're going to do is we are again going to simply use a singular area variable, sort of as a temporary variable. Technically speaking, we don't need it. It just makes the code a little bit more readable. And we're going to do our same calculation over again. So it's going to be pi times, and in this case, it's going to be the radius squared. And since I'm dealing with a singular value, I don't have to worry about using the dot caret notation. And what we'll do is we'll do the same thing that we did before. We will simply increment our index to be able to provide the proper location to store this new area. And then I'm going to go ahead and do another display and an sprintf. And what I want to do is I want to display a few things here. I want to go ahead and display the index so that we can appreciate where this value is going. I'll go ahead and display the radius one more time, even though it is a little bit redundant at this point, and that is going to be the percent point for f to allow for 4 decimal places. And then ultimately, let's go ahead and display the area again with the percent point for f. And then we just simply need to drop into those 3 placeholders the appropriate variables. I'm going to go ahead and adjust my layout just a little bit so we've got enough room to get all this code in. You can optionally go ahead and close the variable editor at this point if you would like. And then for that first placeholder, just simply gets the index. The second one gets the radius, and the third one gets the area. And at this point, then, hopefully you can start to see how we're going to store the individual areas in the areas vector. And that is just simply going to be areas, parentheses, index is equal to that individual area. Now, again, I'm going to be very selective here about running these lines of code. I'm going to actually go ahead and take just a second to break these up with a comment. I'm going to call this one our second try. And again, these are just alternate ways of doing roughly the same thing with some added benefits, in this case, of one of the warnings disappear. But we'll go ahead and run this block of code real quick, and you'll see that we're accomplishing the exact same thing that we did in the earlier for loop. As a matter of fact, we get the exact same values. The big difference, of course, is that we're not getting that warning from Matlab that says that we are resizing the vector every iteration. And again, when you are dealing with hundreds or rather thousands or even millions of iterations, you could see a performance benefit. And again, if you were doing several thousand or millions of iterations, you probably also wouldn't want to display them on the command line because that also would cause a performance hit. Now, before we leave this topic, what I would like to do is I'd like to also go ahead and show you how to display the results of a vector that you already have. In other words, basically, if you think about it, we are displaying something inside of the same for loop that is creating the vector. Well, that's kind of cheating, if you would, because sometimes you aren't going to get that scenario. In other words, you might be given a vector and you simply want to loop through all of the values and display all of the values. Well, the same thing that we can do with the for loop leveraging the radii, well, it turns out we can sort of do the exact same thing with the for loop, but this time what we're going to do is we're going to leverage the length or the size of the areas vector. And we'll cover this a little more in depth in another video, but I just want you to see how we're going to go about doing it. Again, what we're going to do is we're going to leverage that index variable, but this time we are going to have a little bit of control over where it starts, where, or rather how it increments. And then what we're going to do is we're going to use the length of the areas vector to control when it stops. And now what we can do is we can have a simplified display with an sprintf. And again, what I'm going to do is I'm going to have my index with a %d followed by the area equal to a percent point for f. And then for that first placeholder, it just simply gets the index. And in that second placeholder, we will get the areas, parentheses, the index. And essentially what this does is this will then allow for us to loop through each of the elements in an existing vector or one-dimensional array. And what we're going to do is we're simply going to print out the index followed by whatever value is stored at that location in the vector. And again, this will work regardless of the size of the vector or the length of the vector. You just simply need to check to see the size or the length to control then how many times this loop runs. So hopefully you found this video useful. As always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.